Right now, as I speak these words on October 26, 2025, an object the size of Manhattan is hiding behind our sundae. You cannot see it. Earth-based telescopes cannot observe it. It reached solar conjunction 5 days ago on October 21st, positioning itself precisely on the opposite side of our star. In 8 hours and 43 minutes, it will pass through perihelion, its closest approach to the Sun, at exactly 203 million kilometers. The timing is impossible to ignore. This is 3I divided by Atlas, the third confirmed interstellar visitor to our solar system, and the data we have collected over the past 117 days has fundamentally challenged everything we thought we understood about objects from beyond our stellar neighborhood. I am Michio Kaku, theoretical physicist, and for 5 decades I have studied the cosmos through the lens of mathematics and observation. I have always been a skeptic. I follow the evidence. I do not jump to conclusions. But what I am about to share with you represents a convergence of anomalies so statistically improbable that the scientific community has been forced to consider scenarios we previously dismissed as the domain of science fiction. The International Asteroid Warning Network, an organization that coordinates planetary defense efforts across 47 nations, announced on the exact day of solar conjunction that they are launching an unprecedented monitoring campaign for this object. They have never done this for a comet before. They are treating 3I divided by Atlas differently. The question is, why? Let me be absolutely clear about what we are dealing with. On July 1st, 2025, the Asteroid Terrestrial Impact Last Alert System telescope in Rio Hurtado, Chile, detected a rapidly moving object at a distance of 4.5 astronomical units from the sundae that is roughly 670 million kilometers, well beyond the orbit of Mars. Initial brightness calculations suggested something enormous, perhaps 20 kilometers in diameter. For context, the first interstellar object we ever detected, 1I divided by Oumuamua in 2017, measured roughly 100 meters. The second, 2I divided by Borisov in 2019, was estimated at around 1 kilometer. If 3I divided by Atlas truly measures in the range suggested by Hubble Space Telescope observations, between 5 and 6 kilometers in diameter at minimum, we are looking at an object 1,000 to 1 million times more massive than its predecessors. This is the first anomaly. Let that sink in. Think of interstellar space as an ocean. Small boats are common. You see them everywhere. Large ships are rare. Aircraft carriers are exceptionally rare. The probability of detecting an aircraft carrier before you have seen 100,000 small boats is astronomically low, roughly 1 in 10,000 based on the known distribution of debris in the interstellar medium. Yet, here we are. We detected 2 small objects, then immediately found something 1 million times heavier. The statistical likelihood of this sequence, according to calculations published by researchers at the Harvard-Smithsonian Center for Astrophysics, is approximately 0.01%. That is the first crack in the foundation of natural explanation. Now consider the trajectory. Every object entering our solar system from interstellar space should arrive from a random direction. The galactic disk contains stars moving in epicyclic motion, up and down, in all directions relative to one another. When 1I divided by Oumuamua arrived, its orbital inclination was 123 degrees relative to Earth's orbital plane. The ecliptic, when 2I divided by Borisov arrived, it came in at 44 degrees. These are the angles we expect, random orientations from the randomness of stellar motion. 3I divided by Atlas arrived aligned to within 4.89 degrees of the ecliptic plane. Think of the ecliptic as a flat disk containing all the planets orbiting the sundae. This object threaded through that disk almost perfectly. The probability of this alignment occurring by chance is 0.2%. This is the second anomaly. Here is where it becomes deeply unsettling. When you plot the trajectory of 3I divided by Atlas forward through time, you discover something remarkable. On October 3rd, it passed within 29 million kilometers of Mars. ESA's Mars Express and ExoMars Trace Gas Orbiter attempted observations during this close approach. The images they returned showed only a fuzzy white dot, but spectroscopic instruments detected something no one anticipated. On November 3rd, it will pass within 97 million kilometers of Venus. On December 19th, it approaches Earth to within 270 million kilometers, still far away, but closer than its approach to any other rocky planet except Mars. Then, on March 16, 2026, it will pass within 46 million kilometers of Jupiter, close enough for NASA's Juno spacecraft to conduct detailed observations. This object has threaded a needle through the inner solar system, coming within observation range of 4 planets in sequence. Random interstellar debris does not do this. Statistically, it should not do this. This is the third anomaly. But the most disturbing element is not what 3I divided by Atlas is doing, it is when it is doing it. Perihelion occurs today, October 29th at 11:36 UTC. Earth is on the opposite side of the Sunday. We cannot observe the object during its most active phase. In astronautics, there is a principle called the Oberth effect. When you want to change a spacecraft's trajectory most efficiently, you burn your fuel at the point of maximum velocity, which occurs at perihelion, closest approach to the star. If you wanted to slow down, speed up, or release smaller probes to multiple destinations, this is exactly when you would do it. And 3I divided by Atlas will be completely hidden from Earth-based observation at precisely that moment. Some might call this coincidence, others call it timing. This is the fourth anomaly. Let me walk you through the observational data chronologically because the devil lives in the details. Pre-discovery observations from the Zwicky Transient Facility and other automated sky surveys revealed that 3I divided by Atlas was already bright and active as far back as May 7, 2025, when it was 6.4 astronomical units from the Sunday. That distance is beyond Jupiter's orbit. Comets typically become active much closer to the Sun, when solar radiation heats their icy surfaces enough to trigger sublimation of water ice. But 3I divided by Atlas was glowing at a distance where water remains frozen solid. Spectroscopic analysis by the James Webb Space Telescope conducted on August 6 revealed why. The object's coma, the cloud of gas and dust surrounding it, showed an 8-to-1 ratio of carbon dioxide ice to water ice. Typical comets from our own Oort cloud show ratios closer to 1 to 8, the exact opposite. This object contains only 4% water by composition. That is unprecedented. This is the fifth anomaly. On July 21st, the Hubble Space Telescope captured the highest resolution image of 3I divided by Atlas to date, when the object was 446 million kilometers from Earth. The image revealed something that violates standard cometary physics. Most comets produce tails that stream away from the Sun, blown by solar radiation and the solar wind. 3I divided by Atlas showed a jet, a narrow column of material 10 times longer than it is wide, pointing directly toward the Sunday. Astrophysicists call this an anti-tail, and while they can occur under specific geometric viewing conditions, those conditions create optical illusions. Analysis by astronomers at the Teide Observatory confirmed that the 3I divided by Atlas anti-tail was not an optical illusion. It was real, physical material being ejected toward the Sun against the pressure of solar radiation. By September, this jet had reversed direction and began forming a conventional tail, pointing away from the Sun, exactly as heating increased and the object approached perihelion. Models published by researchers at Harvard suggest this transition is consistent with carbon dioxide sublimation physics, but the initial sunward jet remains unexplained by natural cometary processes. This is the sixth anomaly. Now we arrive at the chemistry, and this is where the data becomes genuinely disturbing. In August, independent spectroscopic observations detected nickel emission lines in the coma of 3I divided by Atlas. Nickel is not unusual in comets. What is unusual is that these observations showed nickel without corresponding iron lines. In nature, nickel and iron are almost always found together because they form together in the cores of dying stars and are scattered through space in supernova explosions. The ratio of nickel to iron in cosmic dust is well established, roughly 1 to 16. But 3I divided by Atlas is emitting nickel-rich compounds, specifically nickel cyanide and other organometallic molecules, with virtually no iron signature. On Earth, the only place we see pure nickel compounds in this configuration is in industrial processes, in steel production, and specialized alloys designed for high-temperature applications. The natural explanation requires exotic formation conditions in the comet's parent stellar system, perhaps a collision between a metal-rich planet and a carbon-rich body, but no such collision debris field has ever been observed around other stars, and we have surveyed thousands of systems with infrared telescopes sensitive to warm dust. This is the seventh anomaly. Here is where things take a turn into territory I would have dismissed as pseudoscience just 6 months ago. When astronomers calculated the approach trajectory of 3I divided by Atlas and traced it backward through space, they determined its arrival vector, the direction from which it came. The object originated from a region of sky in the constellation Sagittarius, 9 degrees from the coordinates of the famous WOW signal detected on August 15, 1977 by the Big Ear radio telescope at Ohio State University. That signal remains the strongest candidate for an extraterrestrial radio transmission ever detected, a 72-second burst at exactly the frequency where neutral hydrogen emits and absorbs radiation, the universal signpost that any technological civilization would recognize. The signal has never repeated. For 48 years, we have pointed every available radio telescope at that patch of sky and heard nothing. Now, an object exhibiting multiple physical anomalies arrives from that same direction. The angular separation of 9 degrees corresponds to millions of light years at interstellar distances, so this could easily be coincidence. But when you stack coincidences, when you accumulate improbabilities, the foundation of natural explanation begins to show cracks. This is the 8th anomaly. Let me be clear about what I am not saying. I am not claiming that 3I divided by Atlas is an alien spacecraft. I am not claiming it is artificial. What I am saying is that we have an object exhibiting 8 independent anomalies, each of which could be explained away in isolation, but which together create a pattern that does not fit comfortably within our understanding of natural interstellar debris. Dr. Avi Loeb of Harvard, a colleague I respect, despite our occasional disagreements on interpretation, has proposed a ranking system for anomalous objects, a scale from 1 to 10, measuring the likelihood of technological origin. He has assigned 3I divided by Atlas a rank of 4, which translates to unusual but not conclusive. I would place it at 3.5. The evidence is compelling enough to warrant serious scientific attention, but not sufficient to overturn the null hypothesis that this is a natural object with unusual properties formed under extreme conditions we have not yet observed elsewhere. Let me walk you through 3 possible scenarios, ranked by likelihood. Scenario 1, the benign interpretation. 3I divided by Atlas is a completely natural comet that formed in a stellar system with highly unusual chemistry. Perhaps its parent star went supernova and enriched the surrounding debris disk with exotic isotopes and metal ratios not found in our solar system. Perhaps it formed from the collision debris of 2 planets, one rocky and metal-rich, the other a carbon-rich ice giant, creating a hybrid body unlike anything in our own Kuiper belt. The ecliptic alignment could be pure coincidence, a random roll of the cosmic dice that happened to land on a statistically improbable number. The sunward jet could be explained by asymmetric outgassing from a rotating nucleus with uneven surface composition, though the specific geometry required makes this uncomfortable. The nickel emissions could result from a fractionation process during formation that we do not yet understand, where lighter metals were preferentially incorporated into icy material while heavier iron sank into a differentiated core. This scenario requires no new physics, only unusual circumstances. It is the most conservative interpretation, and it may very well be correct. Scenario 2, the warning interpretation. What if 3I divided by Atlas is natural but its arrival is not accidental? Consider the possibility that other civilizations, perhaps hundreds or thousands of them throughout the galaxy, have developed the same technological capabilities we are beginning to develop now. They can detect exoplanets. They can analyze atmospheric compositions from light years away. They can identify biosignatures, the chemical fingerprints of life. If they detected Earth a century ago, they would have seen oxygen and methane, clear signs of biology. If they detected Earth 30 years ago, they would have seen chlorofluorocarbons, clear signs of industry. They would know we are here. They would know we are young. They would know we are vulnerable. In this scenario, 3I divided by Atlas is a monitoring station, a passive probe sent to observe our solar system during a critical period of our development. It approaches during perihelion, when it can use the sun's gravity to adjust its trajectory or deploy smaller instruments. It aligns with the ecliptic to maximize observation opportunities of all inner planets. It exhibits unusual chemistry because it was constructed, not formed, using materials from a stellar system with different elemental abundances than our own. It is not here to communicate, it is here to watch. This scenario requires advanced technology, but not physics beyond what we can imagine with our current understanding. It is less likely than Scenario 1, but not impossible. Scenario 3, the diagnostic interpretation. Consider an even more unsettling possibility. What if 3I divided by Atlas is part of a network? What if civilizations seed the galaxy with self-replicating probes that use raw materials from comets, asteroids, and interstellar dust to construct copies of themselves, spreading exponentially across thousands of star systems over millions of years? This is the von Neumann probe concept, named after mathematician John von Neumann, who first formalized the mathematics of self-replication. In this scenario, 3I divided by Atlas is not unique. It is one of potentially millions of such objects drifting through the galaxy, using cometary camouflage to avoid detection. The probe hibernates during interstellar transit, conserving energy across thousands of years of travel. When it enters a star system with planets, it activates, surveys the system, and determines whether the system contains life or technology. If it detects technology, it moves into an optimal observation position, which happens to be aligned with the planetary plane for maximum coverage. It uses perihelion to perform maneuvers while hidden from the system's inhabitants. If it determines that the emerging civilization poses no threat to itself or to galactic stability, it moves on. If it determines otherwise, it does something else. We do not know what that something else might be. This scenario requires technology far beyond our current capabilities, but nothing that violates known physics. It is the least likely interpretation, but its implications would be profound. Now comes the critical question. How do we determine which scenario is correct? The answer is observation, systematic observation, following established protocols without preconceptions. And here is the terrifying part. We are about to get our answer. Over the next 73 days, from late November through early February 2026, 3I divided by Atlas will be observable from Earth as it moves away from the Sun and into the pre-dawn sky. The International Asteroid Warning Network has announced an unprecedented astrometry campaign beginning November 27th and running through January 27th. They are specifically training observers on techniques to extract accurate positional measurements from cometary objects, using 3I divided by Atlas as the target. On the surface, this sounds like a routine calibration exercise. But why this object? Why now? The subtext is clear. They are looking for trajectory deviations, any change in velocity or direction that cannot be explained by gravitational forces and outgassing alone. ESA's Jupiter Icy Moons Explorer spacecraft, currently in transit toward Jupiter, will observe 3I divided by Atlas throughout November, using multiple instruments including cameras, spectrometers, and particle detectors. The spacecraft is closer to the Sun than Earth and has a different viewing angle. Any discrepancies between Earth-based observations and JUICE observations would be immediately apparent. NASA's Juno spacecraft, currently orbiting Jupiter, will observe the object in March 2026 during 3I divided by Atlas's close approach to Jupiter. If the object has changed course, released smaller probes, or exhibited any behavior inconsistent with a passive comet, these spacecraft will detect it. The data will not return to Earth until February 2026 due to communication delays and the spacecraft's current position, but when it arrives, we will know. Here is what to watch for in the coming months. First, look for fragmentation. Natural comets approaching the Sun often break apart due to thermal stress, tidal forces, or rapid rotation induced by asymmetric outgassing. Comet Shoemaker-Levy 9 famously broke into 21 fragments before crashing into Jupiter in 1994. Comet 332P divided by Ikea Murakami disintegrated in 2016 due to rapid spin. If 3I divided by Atlas is a natural comet, particularly one with low structural strength due to high carbon dioxide content and low water content, it should show signs of fragmentation as it rounds perihelion. If observations in late November show multiple objects where there was previously one, the natural interpretation gains substantial weight. If the object remains intact, despite the extreme thermal and tidal stresses of close solar passage, that itself becomes another data point requiring explanation. Second, look for non-gravitational acceleration. Every comet exhibits some degree of non-gravitational acceleration due to the rocket effect of outgassing. Material sublimating from the sun-facing side creates thrust, slightly altering the comet's trajectory. This effect is well understood and predictable based on the comet's brightness, spin rate, and composition. Analysis of 3I divided by Atlas observations through September 23rd by researchers at the Minor Planet Center calculated that the object's non-gravitational acceleration is remarkably small, less than 15 meters per day squared, despite vigorous outgassing observed by multiple telescopes, including the James Webb Space Telescope. The current mass loss rate is approximately 150 kilograms per second. For such a small object to resist trajectory changes from this level of outgassing implies either an extremely massive nucleus or an internal stabilization mechanism. Precise astrometry over the next 2 months will determine whether the object's trajectory deviates from predictions in ways that cannot be explained by outgassing alone. Third, look for changes in activity patterns. Natural comets become more active as they approach the Sun and less active as they recede. The brightness curve should follow a predictable pattern based on solar distance and the sublimation temperature of the object's primary volatile component, which spectroscopy indicates is carbon dioxide in the case of 3I divided by Atlas. If brightness changes deviate from this pattern, if the object becomes suddenly brighter or dimmer without corresponding changes in distance, if spectroscopic observations reveal new emission lines not present in earlier observations, these would constitute departures from expected behavior. The Vera C. Rubin Observatory, which recently became operational and can detect over 2,000 asteroids in 10 hours of observation, will be monitoring 3I divided by Atlas throughout its observable period. Any anomalies will be caught. Fourth, look for companions. If 3I divided by Atlas is a mothership deploying smaller probes, those probes would initially travel close to the parent object, but gradually separate due to small velocity differences and solar tidal forces. Over weeks and months, this separation would become detectable as multiple objects appearing near the original trajectory. The Galileo Project observatories, a network of instruments specifically designed to search for technological signatures in the near-Earth environment, are actively monitoring the sky for any unusual objects that might correlate temporally with 3I divided by Atlas's perihelion passage. Automated sky surveys like Pan-STARRS and the Catalina Sky Survey will also capture any new objects entering the inner solar system. Fifth, and perhaps most critically, look for the object's behavior after solar conjunction. When 3I divided by Atlas emerges from behind the Sun in early November and becomes observable again, will it be the same object? Will its brightness match predictions? Will its coma structure remain consistent with pre-perihelion observations? Will the anti-tail have permanently transitioned to a conventional tail as models predict? Or will we see something unexpected, something that forces us to revise our models? The 8-day window when the object was hidden behind the Sun, from October 21st through October 29th, represents a blind spot in our observations. If something happened during that window, a course correction, a deployment, a structural change, we will only know when we reacquire the object. The fundamental question underlying all of this analysis is epistemological. How do we distinguish unusual natural phenomena from technological signatures? This is not a trivial problem. Nature is inventive. The universe has had 13.8 billion years to explore every possible combination of chemistry, physics, and dynamics. Many natural processes produce structures that superficially resemble designed objects. Pulsar signals initially appeared so regular that astronomers briefly considered artificial origins before understanding neutron star physics. Tabby's star exhibited bizarre dimming patterns that sparked speculation about megastructures before dust clouds became the favored explanation, though debates continue. Fast radio bursts were mysterious and potentially artificial before we understood magnetar physics. The history of astronomy is filled with examples of apparent anomalies that resolved into natural explanations once we understood the underlying physics. But that same history also contains a darker current, a reluctance to seriously consider possibilities that challenge paradigms. When meteorites were first reported falling from the sky, the French Academy of Sciences dismissed such claims as peasant superstition. When Alfred Wegener proposed continental drift, geologists mocked him for decades until plate tectonics was confirmed. When Barbara McClintock discovered jumping genes, she was ignored for 30 years until mobile genetic elements were verified. Science is conservative by necessity, but that conservatism sometimes blinds us to genuine anomalies. The question is not whether 3I divided by Atlas could be artificial. The question is what evidence would convince us either way, and whether we are willing to follow that evidence wherever it leads. I want to emphasize something that often gets lost in these discussions. The search for extraterrestrial intelligence is not fringe science. It is mainstream astrophysics. We have spent billions of dollars building radio telescopes to search for signals. We have designed interstellar messages and launched them on Voyager spacecraft. We have constructed elaborate arguments about the Fermi paradox, asking why we have not detected alien civilizations if they are common. The Drake equation, formulated by Frank Drake in 1961, estimates the number of communicating civilizations in our galaxy by multiplying factors including star formation rate, fraction of stars with planets, and probability of life emerging. Even conservative estimates suggest thousands of technological civilizations should exist within our galaxy. If they exist, where are they? And if they are here, observing us from a distance using camouflaged probes that look like comets, would we recognize them? The honest answer is probably not. We have been searching for radio signals for 60 years and found nothing conclusive. We have been imaging exoplanets for 20 years and found thousands of worlds, but no definitive biosignatures. We have been monitoring near-Earth objects for decades and cataloged hundreds of thousands of asteroids and comets, none of which showed clear technological signatures. Our search strategies assume that alien technology will either announce itself clearly with radio transmissions or remain completely invisible. We have not seriously considered the middle ground, objects that are visible but ambiguous, natural enough to blend in, but anomalous enough to generate questions when examined closely. 3I divided by Atlas may be the first object that falls into this category, or it may simply be a strange comet that happened to accumulate 8 coincidental anomalies. The data will decide. Here is what I can tell you with certainty. Within the next 90 days, we will have answers. The object is being tracked by more telescopes than any comet in history. Data is being collected across electromagnetic spectrum, from radio to ultraviolet. Multiple spacecraft will obtain close-range observations. The astronomical community is watching, and the data will be public. If 3I divided by Atlas exhibits behavior that cannot be explained by conventional cometary physics, we will know. If it fragments, outgasses, and fades exactly as natural models predict, we will know that too. This is how science works. We form hypotheses, we collect data, we revise our models based on evidence. No conspiracy, no cover-up, just systematic observation and analysis. But make no mistake, the implications of this object, regardless of which interpretation proves correct, are profound. If 3I divided by Atlas is natural, then our models of interstellar chemistry and dynamics need revision. We need to understand how such unusual compositions and trajectories arise. We need to explain why this object differs so dramatically from the two previous interstellar visitors. These are good problems to have. They expand our knowledge and refine our theories. If 3I divided by Atlas is artificial, if even 1% of the anomalies cannot be explained naturally, then we face a different kind of problem, one that changes everything about our place in the universe. For 70 years, we have asked the question, are we alone? We have sent signals into space hoping for a reply. We have listened to the stars hoping to hear a whisper. We have searched for microbial life on Mars, in the oceans of Europa, in the atmosphere of Venus. We have asked the question in every way we know how. But perhaps we have been asking the wrong way. Perhaps the answer is not coming from distant stars. Perhaps the answer is already here, moving through our solar system, hiding in plain sight among the comets and asteroids we catalog and dismiss. Perhaps the universe is not silent. Perhaps we simply have not learned to recognize the language. In the coming weeks, I encourage you to follow the observations. NASA maintains a public webpage dedicated to 3I divided by Atlas with updated images and trajectory data. The Minor Planet Center publishes astrometric observations daily. ESA will release JUICE observations in February 2026. The scientific papers analyzing this object will appear in journals like Nature, Science, Astrophysical Journal. Stay informed, watch the data, form your own conclusions. This is the timeline we are on now. History is unfolding in real time. Whether that history involves discovering a new class of exotic natural objects or confirming that we are not alone in the universe remains to be determined. Either way, by early 2026, we will know more about what lies beyond our solar system than we have ever known before. I want you to subscribe to this channel not for entertainment, but because the next 73 days represent a critical window in this investigation. When JUICE data arrives in February, when the astrometry campaign completes in late January, when analysis papers are published in the spring, I will walk you through every significant finding, every anomaly explained or unexplained, every revision to our understanding. This is not speculation. This is not science fiction. This is observational astronomy conducted by hundreds of professional scientists, following established protocols and publishing their results in peer-reviewed journals. The story of 3I divided by Atlas is the story of how science confronts the unknown, how we distinguish signal from noise, how we follow evidence even when it leads toward uncomfortable conclusions. And here is my question for you. After everything I have presented, after walking through 8 independent anomalies and 3 competing interpretations, what do you believe? Are we looking at an unusual but ultimately natural comet with a rare combination of properties? Or are we looking at something that demands a different kind of explanation? Leave your thoughts in the comments. But more importantly, tell me what evidence would change your mind. What observation would convince you that 3I divided by Atlas is natural beyond any doubt? What observation would convince you that it is not? Because the value of this discussion lies not in the conclusions we reach, but in the rigor with which we examine our reasoning. Science advances when we are willing to be wrong, when we state our hypotheses clearly enough that they can be tested and falsified. 3I divided by Atlas reaches its closest approach to Earth on December 19, 2025, exactly 54 days from today. Mark that date. On that day, the object will be within optimal observation range for ground-based telescopes. Amateur astronomers with 8-inch telescopes or larger will be able to observe it directly. Universities and observatories worldwide will be collecting data. If anomalies exist, they will be visible. If the object is natural, that will be visible too. The universe does not lie. It shows us what is there if we are patient enough to look and honest enough to accept what we see. Right now, at this moment, 3I divided by Atlas is behind the Sunday. We cannot see it. We cannot observe what it is doing during its closest solar passage. That blind spot, that 8-day window of darkness, is where the answer may be hiding. In 3 weeks, when the object emerges and becomes visible again, we will begin to understand. Until then, we wait. We analyze the existing data, we prepare our instruments, we formulate our questions, and we remember that the greatest discoveries in human history have always come from moments when reality refused to conform to our expectations, when nature surprised us, when the universe revealed itself to be stranger and more magnificent than we imagined. Are we alone in the universe? For decades, that question has been abstract, philosophical, distant. With 3I divided by Atlas, it has become immediate, testable, observable. The answer, whatever it is unfolding now. Not in some distant future, not in some far-off star system. Here, now, in our solar system, moving past our planets. Visible through our telescopes, and within 90 days, we will know. This is Michio Kaku. The evidence continues to accumulate, the timeline continues to unfold, and the universe, as always, will have the final word.